Alright, welcome to 7.2 Notes Finding Missing Angles using trig. You remember last time we did missing sides using trig, and this is going to be very similar to that. Alright, first of all I want you guys to remember chief, so, what's the last part? Toa, that is correct. Alright, so on your paper, I just want you to write a nice T here, and under ratio, write sides, because this is how we find sides. So our so is sine of x equals opposite over hypotenuse, right? Our is cosine of x equals AH, adjacent over a hypotenuse, and then toa is tangent of x equals oa, o opposite over adjacent. Alright, and that's how you find the sides, a missing side. But if you're looking for a missing angle, you're going to go about it a little bit differently. You're going to say that angle x equals the inverse sine of your opposite over hypotenuse. Now, what is inverse sine, you ask? Well, we'll get to that in just a little bit, but right now just go ahead and write these guys down because you'll want to have this written down. For cosine, it's just the measure of the angle x equals inverse cosine of adjacent over hypotenuse, that's your ka, and then your toa, once again, the measure of the angle x equals the inverse tangent of opposite over adjacent. So now that we've gotten these guys written down, let's take a look at our calculator check here. Remember, you want to make sure that your calculator is in degrees, not radians. We went over that in 7.1. If this stuff is not working for you, if you're getting some wonky numbers, make sure you just hit the mode button on your calculator and highlight the degrees. Okay, and for a more detailed explanation, you can look at the 7.1 notes. But let's look at our calculator check here. We've got the sine of angle A equals 0.7230. Okay, now this is where the inverse of all that stuff comes in. So I've got my sine. I'm going to take my inverse sine of angle A. Now if I take my inverse sine of a sine, guess what happens to those guys? Boom. They cancel out. And what are you just left with? Angle A. That guy comes right down there, okay? However, what you do to one side of an equation, you've got to do to the other side as well. So angle A equals the inverse sine of 0.7230. Now, once you've got it down to this equation, then it is easy because all you have to do is find this little button on your calculator. Now, you're going to find the sine button, and then just above the sine, written in blue, you're going to see something that says inverse sine. Okay? So on your calculator, you're just going to hit the second button that's on the upper left hand. It's the one that says second, right? And then you're going to go over and you're going to hit sine. And so that's going to give you inverse sine. It's going to say inverse sine on your little screen there. So hopefully you have that. So go ahead and do that. And then in your parentheses, you're going to just write this number right here. Okay, go ahead and do that. Press pause and come back to me once you've done it. Okay, so you should get that the measure of angle x is 46 degrees. Now it's 46 and some change, but for angles, we're going to round to the nearest whole number. So we're just going to say 46 degrees. All right. So let's take a look. We've got all this stuff right here. If you need to write any of this down, remember, just pause the video and get anything that you're not caught up with here. But let's go up to example number 1 and put this to work. Okay. So I'm going to start, like we said in lesson 1, I'm going to start with my angle, whatever my angle is. Here's the corner of my triangle, remember, is my angle, and I've got my x. And then I've got a side that touches that angle. And so that's going to be my adjacent side. Remember, my adjacent side touches the angle. And then I've got the long side of my triangle. And the long side of my triangle is always the hypotenuse. Remember, it's the side that is opposite the 90-degree angle, right? So I've got my adjacent, I've got my hypotenuse. I have to remember from SOHCAHTOA which one deals with the A and the H. And that would be my CA of SOHCAHTOA. I've got my A and my H right here. So that's cosine. All right. So I'm going to scoot out a little bit here. And I'm going to say that cosine of x, remember here's my x right here, cosine of x equals adjacent over hypotenuse. My adjacent is 9 over my hypotenuse is 15. And then from there, remember when I'm trying to find an angle, I'm going to use inverse. Angle equals inverse, alright? So I just take the inverse of cosine of both sides. Remember, if I take the inverse of cosine of a cosine, that just cancels out both of those cosines, and all I'm left with is x. But I have to do the same thing to both sides of the equation. So x equals the inverse cosine of 9 over 15. Now I just enter that into my calculator. Remember, I'm going to hit the second button, and then I'm going to hit the cosine button, and then I'm just going to do 9 divided by 15. Go ahead and do that now. I'll wait. And you can press the pause button and do it when you're done, and press play when you're done. Okay, you should have gotten that x is equal to 53 degrees. And remember, it's an angle, so it's in degrees, and we just round to the nearest whole number. Alright? So that was cosine. And I've got, let's see, let's do one with tangent real quick. Once again, I identify what angle I have the measurement for, or what angle they're asking for. In this case, here's my angle that they're asking for. I see that the side that has 6 is opposite my angle, and then I see that the side that they've given me that has 5 is adjacent. It touches the angle, right? So I've got opposite and adjacent, OA. So I'm going to use my TOA. Tangent equals opposite over adjacent. So I'm just going to say tangent of x, that's my x right here, equals my opposite, which is 6, over my adjacent, which is 5. Remember, to find my angle, I'm going to take the inverse. Inverse tangent of tangent, they just cross each other out, and I'm just left with my angle measure there. So that's x equals, of course I have to do the same thing on the other side of the equation, the inverse tangent of 6 over 5. And then I just plug that into my calculator. Go ahead and do that now. You might want to hit pause. Okay. you should have gotten x equals 50 degrees. This angle is 50 degrees. Alright. So, we've got these guys right here, all of that stuff, and now we're going to go to our word problems. Let's take a look at example 3 for the word problem. During a storm, a tree trunk breaks 5 feet from the bottom. Okay, so let's see. I've got my tree trunk right here. I guess my tree should be brown. And then it breaks. Now don't laugh at my artistic ability here. 5 feet from the bottom, so that height from bottom to top is 5 feet. And then the top of the fallen tree lands 15 feet away from the base of the tree. Okay, so we've got to draw the fallen tree. Oops. And give it some foliage. Nice happy tree. Alright, and that is 15 feet away, the top of the tree there, from the base of the tree. Okay, and so they're asking me, find the angle that the broken piece makes with the tree trunk. So the broken piece, the angle that the broken piece makes with the tree trunk. So they want this angle right here. So I'm looking at my angle first. I've got my angle, and then I see that my side that is 15 feet is opposite my angle, and then my side that is just 5 feet is touching my angle. It's adjacent. So I've got opposite over adjacent. Remember that's TOA. Tangent of x equals opposite. That's 15 feet over adjacent. That's 5 feet. So take the inverse tangent of both sides. And that cancels out, and I'm just left with this x right here. X equals, and what I do for one side of the equation, I have to do to the other side of the equation. So inverse tangent of 15 over 5. Go ahead and plug that into your calculator. Alright, you should have gotten x equals 71.56, so we'll round to 72 degrees. So that should be 72 degrees. Alright. Well, I'm going to leave you guys to do the rest of these here. And if you have any questions, just find me in tutorials or in advisory. Alright.